In this lecture, we will see how this trig identity can be used to find out sin 15. You will see how it leads to solving a quadratic equation. We know sin 30 and 45. We can break down 45 degrees into 30 and 15. This formula allows us to understand sin 45 in terms of sines of 30 and 15 degrees. Left side is square root of 2 over 2. Right side, cosine 30 and sin 30 are known. So what's not known is sin 15 and cosine 15. So now we have one equation, two unknowns. Equation is a relationship between the components and the outcome. But one relationship can only be used to find out only one unknown. For example, x plus 3 equals to 5 can be used to find out that x is 2. But if both are unknown, then one relationship is not enough to determine them, because there are many possibilities. So looks like we have two unknowns here. But remember, there's also a relationship between sine and cosine, so we want to make use of this relationship. If we move sine to one side and cosine on the other, then square both sides. Expanding the left side, we have 1/2 minus square root of 6 over 2 times sin 15 plus 3 over 4 times sin 15 squared. The right side is cosine squared. It can be written in terms of sine squared. So the extra relationship can be used to express cosine in terms of sine. This way, we've reduced one unknown. Now rearrange, we have sin 15 squared, a term for sin 15, and a constant. They add up to 0. So again, one relationship, one unknown. Now let's see how to solve this equation. This equation involving both the unknown and its squared is called a quadratic equation. If the outcome and one component are known, then we can find the other unknown component by solving the equation. But why this quadratic equation is difficult to solve? That's because we don't just have the unknown component itself. We also have the unknown squared. Because we don't know sin 15, we don't know its squared. So on the surface, we have two unknowns. But fundamentally, there is only one unknown, because if sin 15 is known, so is the squared. That's why, although there is only one relationship, two unknowns, it is still solvable, because these two unknowns are related to one another. But how to solve it? You solve it in two layers. Let's take a slightly different example. If you notice that these three terms can be wrapped up into a compact square, then you can solve it in two steps. First, just take square root of the outcome. 3 plus and minus that equals to the unknown x plus 1. Then you solve x by subtracting 1. This method is called complete the square. It's the classical method to solve a quadratic equation. Let's see how to use it in our case. To make it simpler, let's use x for sin 15. Can we wrap up these terms into a square? So we ask x plus what, when squared, equals to the above. We don't know yet, but if we expand it, we should have x squared, 2ax, and a constant. Now we need to figure out how to match all these terms. X squared matches x squared, so nothing we need to do here. Should we require these two terms the same, or these two? If we require these two equal, then 2a should be minus square root of 6 over 2. But if these two are equal, then a squared should be 1/4. These two requirements will lead to two different answers for a, so which one should we pick? If we go with a equals to 1/2, then we will have an x term we can never match. But on the other hand, if we match the x term by picking the other a, then we'll end up with an extra constant. So in our original equation, if we add such constant, then subtract it, these first three terms form is squared as below. The two constants net to a new constant. Let's move it to the right. Now we have a simpler equation asking us what squared equals to 1/8. Again, we do it in two layers. First, this unknown minus square root of 6 over 4 must equal to plus or minus 1 over square root of 8. Then x is plus or minus 1 over square root of 8 plus square root of 6 over 4. This is our sin15. But there are two possibilities. But sin15 should have just one value, so how to pick? This square root of 6 over 4 is greater than a half, and we know sin15 must be smaller than sin30 because it is a smaller acute angle. So sin15 must be smaller than a half. Therefore, we should pick the minus term. Then using the relationship between sine and cosine, we can find out cosine 15. So now we have sine cosine 15. In the next lecture, we will see how to find out sin18.